Hey guys, it's Josh from the Update channel, and today we have a special treat. And for the first time, we actually have an actual cat, not just an employee, but basically the head of the research of the C13D, which is the new C13 they're going to be coming out with here. We have Allen Chen from Caterpillar, not a cat dealer. I'm a cat dealer employee. He's a cat employee, and there's a big difference. I have a list of questions that were people had left comments in our comment section on the C13D video, and luckily someone from Caterpillar reached out and said, hey, would you like to talk to the head guy? And I said, well, of course I would. So that's what we're doing here. If you would like, Alan, can you tell us a little bit about yourself and kind of how long have you been working on the C13D project?
Sure. Maybe to start off, set the record straight, I am definitely not the head of research. I've just been working on this engine for quite a while. You can maybe consider me the head product marketing specialist for this engine after having had worked on it for as many years as I had. It's been 6 years in the making. A little bit background for me, straight out of college from Carnegie Mellon, started CAT in 2012 after having interned. And I started off in the simulation team where we agnostically simulated whatever came our way. It could be 1D, 2D, 3D, didn't matter. Thermal, mechanical, sound, anything. And this could be components, engines, systems, etc. But then I moved over to the design team, I guess in 2017, 6 years ago, yep. And my first job was to figure out cooling systems. Just figure it out. And lo and behold, those were the building blocks to the development of a new engine. I didn't know at the time, I was just told to. But technically the program has started around 2016 from the initial stages of sizing the power, the requirements. But 2017 is kind of when the design work started.
Okay, wow, that's 6 years. That's a lot longer. So this isn't one of my written questions, but so you initially, when you started, you didn't know you were even working on this engine. It sounds like you were just working on cooling systems.
Right. As a design engineer, and at the time, the specific subtitle was integration engineer or configuration engineer. It was a catch-all for engine systems. So good to know how all the different systems work together, cooling systems just being one of them. And historically, the cooling systems is the most complex, touches not only just the engine, but it branches out into the entire vehicle, if you will. Sometimes not a vehicle, sometimes it's just an environment, chassis or something like that.
That's pretty interesting. I figured the cooling system would be not that complicated, but you put coolant in it, moves around. But I'm sure as an engineer, there's a lot more to it than that. But we'll get back on track here. So really, the most common question I got is, I've heard, and to avoid any confusion out there, and this is the most common questions, are there any plans for this to go into any sort of on-highway truck application? Will there be any options for this engine to be used as a crate application for trucks, or perhaps a different application that it wasn't specifically designed for?
No. The simple answer is no. Complicated answer is no. There are no plans for this engine to be on highway trucks, or any kind of crate application that you can drop into an on-highway truck. This engine was specifically designed for off-highway, heavy-duty applications.
The best way to answer it's a simple answer, for a complicated question. So one of the other comments I keep seeing is a lot of people seem to think this is another manufacturer's engine and just has a cat sticker on it. You would know more than anyone. Is this in fact a 100% cat designed and going to be manufactured engine?
100% authentic Caterpillar Enterprise designed engine. Clean sheet from the ground up. Literally started from a napkin sketch. Maybe we'll call it a tissue paper. It was a napkin.
Okay.
But I can name the original startup, or if you will, Skunk Works teams. There was a limited number of us before it became more streamlined and formal. And to this date, there are 82 patents on this engine.
Wow.
If that's testament to how original this engine is from Caterpillar.
Okay. Wow, 82. That's a lot. I'm surprised there's that many changes on just one engine, but I guess when each system can have a patent, you can really stack them up. But
Yes.
okay. Well, I got a lot more questions there. I got two whole double-sided pages, but those are, the main two questions I seem to be the most. But one thing I was wondering was Cat has been making the C13 engine for quite a while, and is this just a newer version of the older C13? One of my favorite Cat engines, the old KCB C13 compound turbo system. Or is this a complete built from the ground up design of a block, cylinder head, gear train, fuel system, all that stuff?
Yes. Yes. So firstly, people might think because it's just a different suffix of the C13 that it's just some new iteration or slightly newer version. But in fact, like I said before, it is complete built from the ground up, new gear train, new head, new block, new layout, new parts. Um, and the reason why we kept the C13 in the name is just because of the heritage. People know that C13. This is in fact a 12.9 liter, so you can say it rounds up to a 13. But people know the C13, and we wanted to continue that legacy as a durable and reliable engine.
It's good to know. That's cool that it's a completely new casting. It's not not a 3400 series. You're just taking
No,
the old grinder too.
no, yep.
So looking at the pictures and in the previous video, I'm sure you've seen it or at least know of it, but I didn't seem to notice any sort of NRS system on this engine, which if you're not familiar with Cat's terminology, that's Cat's term for a Knox reduction system, or EGR is what most people call it. I didn't see any sort of NRS cooler on it. And with that question, it kind of opens up two questions, which is what is the Knox reduction strategy on this exactly? And does that tie in any way with what Cat used to use with the IVAs, or also known as VVA systems?
So, as you've correctly noticed on the engine, there's no EGR or exhaust gas recirculation system, or NRS, as you mentioned it. The customers that we hear from, they don't want that complexity, and it results in extra fuel savings anyway when we remove that system. The Knox strategy actually just comes from both the aftertreatment, which has an SCR for the higher regulated country ones, but most importantly, more efficient combustion. Because this is a clean sheet engine, this is not the unit injectors anymore, the mechanical electric unit injectors, the MUIs. This is a common rail. So we utilize a common rail, pressures as high as 250 MPa. New compression ratio, 18:1. So you have a cleaner combustion. You have more airflow coming in from a new turbo. It's a variable turbo, in fact. And you won't see any variable valve actuation on it. Like you mentioned, the VVAs. There's no VVAs. There's no IVAs. Nothing built in like that. The only kind of variable valve timing that might happen would be related to engine brakes in future iterations of this platform.
Okay, well, that was a very thorough answer for that one, but that's good to know, because I know you said maybe potentially in the future, but having both systems, it seems like both the NRS and then the SCR system at the same time from the get-go is just very complicated, as you know. So,
Yep, absolutely.
so you were talking about the overhead there with I almost called them Jakes. They're not Jakes, compression brakes, right?
Compression brakes.
Jakes are a specific manufacturer. It's like saying Kleenex instead of napkin or whatever. But
That's right.
so next question is the information sheet that I had in the video. It said it has hydraulic lifters. Can you tell us more? Because every Cat I've ever worked on doesn't have hydraulic lifters. Does that mean no overhead adjustments anymore? Is this an overhead cam engine, by the way? I didn't see anything on that.
Yeah.
Tell us basically whatever you can tell us about the valve train.
Sure, no problem. So this is not a cam and block like our legacy C13, where the camshaft is located in the cylinder block and then utilizes lifters to go all the way up to actuate the rocker arms. In fact, you've hinted on the right thing. It is an overhead cam because this is a new gear train. We've designed the gear train to reach all the way to the top, so the gear and the camshaft are now inside the cylinder head. Therefore, we call these hydraulic lash adjusters and not so much lifters. The hydraulic actuation that happens in the rockers itself, there are actual high pressure oil lines that run through the rocker shaft and into the rockers in order to actuate a little piston that compensates for the lash. And then of course, in order to, make sure it doesn't get blocked up, there's a little aeration plate above it. But there's some of the design magic, let's just say, it happens in the rocker arm itself.
Okay. So yeah, hydraulic lifters. They make sense in that you don't need to run your overhead anymore, which, especially if you have a clean emissions module on top of that valve cover, really can be very expensive labor-wise. So that makes sense. Be interested to see how that works out. I know some of the smaller Perkins use those, like the 7.1, or not necessarily with the rocker arm and an overhead cam, but they have hydraulic lifters, so similar.
I think you bring up a good point. Not necessarily new technology, as you've alluded to. We have these on our current product platforms, but not in this size range, just smaller, and the really, really large platforms have it already.
Oh, really? What, the C175, or which one has it?
It's one of the two, and I don't know if I could say in this video which one it is unless they've gone public with it.
Okay, I won't get out the shovel and start digging. I haven't seen them before, but I've never worked on a C175 or some of the other ones either, so can't really say. Only 3500s, that's the biggest I've worked on. So we'll get to the next question here. As you alluded to earlier, some of the CAD information had this too. I've heard this engine has several new patents on it. It sounded like 82 from what you said. Can you elaborate? And I know some things you probably can't elaborate on everything, but what new technology that went into making this engine that required so many patents?
Sure. To start off, there were, and still counting, 108 INFs. INFs are invention notification forms. These are forms we fill out before they become part of the patent review process. And then if it passes all that muster, then it becomes a patent. And there are 82 that pass that muster so far. And so we're still in the prototype phase, so there are more to come. A lot of the patents are actually not necessarily around new technologies per se, but also new designs and novel ways to come up with a systems solution, let alone the component solution. So I personally have 11 myself, patents, and I'll give you some of the examples. If you look real hard online for perhaps water jackets pertaining to this engine, being that it's patented, I'm more free to talk about it, you'll find that they are especially unique. I won't bore you with all the details as to how it works, but know that we've spent thousands of iterations and many, many, many nights working on the design of those new water jackets. So something worth a visit.
I mean, that as an engine guy, that seems interesting to me. And like I said, the cooling system just holds coolant. But I guess if you're making lots of power, almost, was it 690 horsepower at 13 liters, or not, just below 13 liters, you're going to have a lot of heat. So it makes sense that so much work would have to go into the cooling system to get that heat out from, not having hot spots and stuff. It makes sense.
Absolutely. Yep.
But let's get to the next question here. This is one I was wondering about, and a lot of people asked. Are all the components on this engine designed by Caterpillar?
Yeah, so as with many of our components, we do indeed partner with manufacturers. If maybe that's what the question's alluding to, we do partner with a lot of manufacturers to optimize on the design. But if you go back to the earlier sentiments, since this is all Caterpillar designed, 82 patents to prove it, the IP would fall under our ownership. So for example, the injectors, if you're curious, are 100% Cat. 100%. The architecture, the IP around these zero static leak fuel injectors, They were leveraged from our C175 that you've mentioned, which I
Okay.
can say, which those engines, when they drop into those machines, they're found in the dirtiest places in the world. I'm talking some of the dirtiest mines in lesser regulated countries. So um, these injectors, for those that are wondering, are 3 times more robust and durable than our MUIs that were historically on the C13. If anyone's questioning their integrity.
I the Mueys in my experience have been super long lasting. I'd see them in trucks with a
Yep.
million miles. So to claim that the
Yep.
common rail ones are up to 3 times, that's insanely high robustness. Not really a term I use, but I know Cat likes to say that.
Yes, yes, you
That's
got it.
pretty crazy. Can you zero leak, zero static leak? Are you referring to there's no fuel return from the injectors, or you mean there's no leaking of the nozzle tip at under pressure or something? I'm not familiar with that term.
So when I say zero static leak, I'll boil it down to when the fuel injector needs the fuel to perform its combustion, it'll get it and only that amount. No more, no less. We do not send fuel continuously, which we've done in past engines, to the injectors and kind
Hmm.
of wash it around the injector body. Sometimes that builds up heat. Sometimes that requires a fuel cooler as a result of said heat gain, but these do not have that feature. There's a built-in valve, for example, another IP item on
Wow.
there where you shut off the fuel. There's still kind of some leakage in the way it returns, but it's not at the injector. It's a completely different part of the system on the rail, in fact.
Wow. That I've worked on a couple different manufacturers, common rails. Some of the cats, like the C7S common rail. That seems totally foreign to not have actual endless fuel delivered to the injector and then the injector. That's pretty cool. That's really
Yep.
interesting. So let's sticking with the engine. I mean, this whole discussion's about the engine, but why was the design determined to use a rear gear train? I mean, every cat that I've ever worked on, at least, I know a lot of other manufacturers have gone to rear gear train. Cat's always had a front gear train, unless maybe you go back to 1693s or some of the really old stuff. So why did you switch to rear gear train?
Okay, so we're talking beginning of this program, one of the bigger architectural tear-ups was this gear train. And at the time, and I mean it's still the case, you'll find a lot of SAE papers out there talking about the advantages of a rear gear train. So the actual, minute details, if you want to get into it, they're more than adequately explained in those papers. But to give you the high level of it, if you can imagine as you fire loads, right, and the connecting rod moves against that crankshaft, you induce some torsional deflections, all right? And if you put the gear train in the front and you deflect the entire crankshaft, you rely solely on the damper to help stabilize some of those variations in load, which then translate into the front gear train. But if you move that gear train to the back, where the giant, dense flywheel is, that can serve secondarily as a stabilizer, if you will, to help dampen out those loads. Now, I don't want to call it a damper because the flywheel is there to preserve momentum, not to dampen loads, but it does help with dampening loads back there. Um, so to increase the durability of the gear train, to increase the durability of the engine, as well as the accessories on the front, like let's say your AC, air conditioning compressor, AC compressor, or some people call it a refrigerant compressor, and your alternator, sometimes those are found on large brackets on the front, which try to move the, component off from the central core component holding it, and you'll have more shaking, more vibration. If now you don't have the front gear train, you can actually put the AC compressor and the alternator straight up to the block,
Hmm.
and the block is nice and stiff.
Yeah,
It dampens out all the loads. So you also secondarily improve the longevity of your accessories.
that's a really good answer. As a mechanic, it's like, I don't know. It seems like it's easier in the front gear train. But yeah, I guess that's why they have engineers and not mechanics building them, because we probably wouldn't even have valve covers or anything. We're just like, it's just in the way. But so this will still have a front damper, I'm assuming, but you're saying it will be less critical, I guess.
I wouldn't say it's less critical. It's
Okay.
still a very critical component to the engine's behavior overall. But the loads induced to the gears will be more stable, and the load deflection will be less, which implies longer life because the gear train's in the back now.
Okay. Well, this one kind of gets into not necessarily tuning, but I get a lot of questions with tuning. And I don't tune engines. I'm a Cat dealer employee, but a lot of people do. And I really ties into fuel systems, because Cats have forever they've used injector trim files and flash files and FLS and FTS, PAR dynos, that type of thing. And basically what I'm getting at is, are the fuel settings going to be similar to the older engines with all those older systems that were somewhat simple, or you got something all new going on?
So I guess it comes down to simple math equations where you have input variables. Now, were those input variables hard coded, like perhaps in a map, or are they now smart? The answer is now they're smart. This is all new, advanced controls. Everything is algorithm based, so you can't tune a map. There are no maps anymore. When the engine is running, because it has digital sensors all around the engine, it will sense where it's at. It'll sense its atmospheric pressures. It'll sense its temperatures. Is it too hot, too cold? Am I at altitude or something like that? And the engine will algorithmically optimize on power, give you the most power you can get, while making sure you use as little fuel as possible. That's why we're saying optimize, all the while meeting emissions. So we call that advanced controls. Gone are the days of mapping and tuning.
All smart, algorithm based. I've never even heard of an engine having an algorithm, but that's pretty interesting. Starting from scratch here, that's pretty cool. Hopefully, obviously that'll be something to get used to than the older Cat guys like myself are familiar with. But that's good to know.
Now, you didn't ask if there were flash files, though. Flash files will still exist because you can move from one rating to another rating with a flash file. It just you don't get a whole suite of maps per se with that flash file anymore.
Okay, well that's
There's
good to know.
still reasons for having it, though.
Okay, so your flash file, similar to current engines, does set what, I guess it sets your software max horsepower kind of, and then it's up to the algorithm now to make that work.
That's right.
Okay. Okay. That's cool. At least kept one thing the same, I guess. So it sounds like, and this ties into pretty much everything we've talked about already, but I'm sure fuel efficiency was a big driving factor for this engine. And I'm sure this could get super complicated. And you're talking to a mechanic here, I'm not an engineer. As simply as possible, how much more fuel efficient could this engine be compared to, let's say, a C15 running at a similar engine load?
You run apples to apples at a similar engine load as a C15.
Right.
You would expect to enjoy a significant fuel consumption benefit. Now, the question is, which load are you referring to along that C15 curve? And in this world of off-highway, where it's not just somebody driving, so it's very predictable in like someone driving on highway where it's very predictable. You go up to a certain miles per hour and then you come down from a certain miles per hour, just to give one example. These off-highway diesel engines are being used in so many different applications. Some of them run our rated condition, or let's just call it full power all the time. But believe it or not, some people use this engine at half power or a quarter power for most of the time. If they're running it at high power, high load compared to a 15, you can save up to 10% fuel consumption. If
Oh,
you run it in like those super low loads, let's say an application that idles a lot, you can get as high as 29% better fuel consumption.
wow.
All again, advanced controls, right? You're optimizing. Now you're not at the mercy of maps and hard code. Now you have liberty to go and optimize on the fuel while meeting emissions.
Oh, it makes total sense. I mean, it had to be more efficient than the 3400s, which were designed, decades ago. And 10%, I mean, that's pretty significant. But it makes a lot of sense, too, that at lower loads, it would increase in efficiency since it's a common rail opposed to, basically having toilets over each cylinder and just flushing them each time with a MUI system. Being a little overdramatic there, but that's a lot
Oh,
more.
you're right. That's a good way to describe it.
But that makes sense, too. With it being a lot more efficient the lower the load is too. And obviously this, I don't know if you know it, but it's got to be a lighter engine than the 3400s also, just being smaller in displacement like the older C13s. So this is the last question I have written down. I almost wish I could have live comments, but if you've ever seen one of my live streams, the questions it would never end. You'd be here, the sun would be down, you just pass out. But the last question I have recorded or here for you is, do you know when this engine will see a release date for the market and in what exact machines or applications is it first being released in?
Sure. So engines are available pilot in 2025 and hits mainstream production in 2026. As far as which machines you'll see these in, I can give you examples of the applications. So we'll start with crushers and screeners that you might find at a mine site, chippers and grinders that you might find handling wood, or even the stuff that makes the mulch that people find in their mulch bed in their yard and stuff. This engine can go into those applications. Drills, again at mine sites, trenching or construction. Sweepers, screeners, pile drivers. The list is compressors. The list is really, really long, and I guess the point is anything that an off-highway, heavy-duty application that requires 340 to 515 kilowatts of power, this engine will be at its doorstep, so to speak.
Okay, and tying in with that question, it sounds like this is strictly industrial initially, meaning Cat engine in a non-Cat crusher or a drill rig, right? Because Cat doesn't make a big mulcher for like a Morbark or something. That's got to be, I'm assuming that's intentional to kind of test it out and make sure it'll work in a wide, weird variety of applications before Cat's like, okay, well, we're going to start putting this in our own stuff.
Sure. And I will say that this engine is an enterprise and global engine. So at the time, if and when our machine friends want to launch or talk about this engine and how it may or may not even be in their line of scope, they'll probably mention something about it. But for where we are today, me talking to you, that's right. This is industrial, third party for machines that aren't part of the current Caterpillar portfolio.
Okay. And maybe this is probably me not knowing, but from the way you said that, I'm assuming you're in a department that is not part of the earth moving department then? You're on your own thing, I guess?
Correct. So we are energy and transportation. We have the divisions that develop the engines. Yep.
Okay.
So earth moving division would be comprised of machines that use various sized engines.
Okay. Well, that sounds like I would want to be in your department then, because I don't really, I'm not as good of an equipment guy as I am an engine guy. So that's pretty interesting.
You're an engine guy. Yep.
Okay, so Alan, we pretty much covered at least most of the big things I can think of. We talked about the fuel system, the overhead, the release date, even stuff about Caterpillar. I'm not Caterpillar. Where's a good place if someone says, hey, I find this pretty interesting. Where can they go find out more about this?
Oh, sure. Yeah. Good question. So if you go on cat.com, our main website, and you navigate over to the industrial section up at the top, you'll find this engine on the front page there. But if you go to directly cat.com/C13D, you'll find a whole marketing launch page surrounding this engine. And you'll find a lot more technical details on that page.
Okay. Yeah. And you don't need to have a Cat login or anything. I can attest to that
Nope.
myself because I've not been logged into Cat, and you can get on that page. It's a customer focused site. So that's easy enough. Cat.com. I can't think of a shorter word to type in than that. So
/C13D if you want to go directly to it.
oh, well, you're getting complicated now. You're adding all sorts of letters and symbols there, but that is easy to find. So yeah, it's easy to find there. Well, I'd like to thank Allen here for spending his highly educated and knowledgeable time talking to me about this engine. And like you said, if you want to learn more about it, go over to cat.com. And Allen, I'd like to say thank you for coming on and answering all my questions.
Thanks, Josh. It was a pleasure being here.
Alrighty, well, we will catch you in the next video.